Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In the last videos we were talking about aliasing and how aliasing and the mutability of arrays can be significant, and I drew pictures that looked like this to illustrate an array. And I hinted at the fact that this really isn't an accurate representation. And to understand that, we can picture a piece of code like one that I have in the book, which is, let's call so get and clear. It takes an array, we'll make it an array of ints, and what I want to do is I want to pass it the index, which is an integer that I want to get back, and then actually instead of calling it, I'll just get and clear, I can just do that. And the idea here is that I'm supposed to return the value at that index. Since it's an array of ints, that index is going to be an integer, and then it's going to set that value to 0. So for an integer, that's about as close as we can get to clearing the value out. So what happens in here is first I create a value, I'll call it ret, and I set it to ARR sub index. Then I set sorry, my Scala or my C++ is coming forward in me. Okay, so we define that line, and now I do this line, except with proper Scala syntax, so that we get index there, and then I set ARR sub index to be 0, and then I give back that value. So if I make a new array, and I call get and clear on that array A, and let's say index sub 3, 0, 1, 2, 3 would be the 4. So what this is supposed to do is it's supposed to give me back the value of 4, and then change the array so that it is 1, 2, 3, 0, 5. And if we run this and we print A, we can see that's indeed what happened. Okay. But if we draw this out and we try to think of what's my image here is, so at the top level we had this array called A, and then inside the function we had two values, ARR and index. Okay, and ARR wound up being an alias for A, and index points to a memory location that I gave it the value 3 when we called it. So we can go back and look at the code to see how this matches up. So, and our array here started off like that. So A was 1, 2, 3, 4, 5. When I call the function, ARR becomes an alias for A, index is 3. Now what happens? Well, I create a local variable ret. So we're going to make a new variable, and it is called ret. And it's this next line that causes us a challenge in this view. This says that ret equals ARR sub index. And if you picture an array like this, it's tempting to think that what happened was something like, I'll just draw it to there, this, where it points, and actually I guess it went to there because the sub 3 index. It's tempting to think that we could somehow point it into the middle of this box at the 4. And it turns out that's not what happens. You cannot make references that point to the middle of objects in the Scala model. It's impossible to do. And so the question is, well, if that's not what happens, what does this line do? And to answer that, we have to actually clean up our picture. I'll pull this arrow over here and picture this array not as just a single box that has 1, 2, 3, 4, 5, but instead picture it as it should be pictured which is 5 boxes. So let's see if I can quickly break this into, it's not going to work so well here. We'll do this. One, 2, 3, 4, 5 boxes. And these 5 boxes do not actually store 1, 2, 3, 4, 5. They store references to the objects 1, 2, 3, 4, and 5. Hopefully you can see why I was a little bit slack in doing my drawings previously, because drawing it this way does take a bit more time. And so what's really going on here is that this first box, let's get rid of that big box that we have in the background. The first box references there. The second box references there. The third box references there. Fourth goes to there. And fifth goes to here. This is a proper image that you should have in your mind. Each of these boxes in an array isn't actually holding a value. It like the variables themselves, are references to other objects, and those objects hold the values. So the way you should picture an array in Scala, and this is also true for lists, whether it's an array or list, you should picture it as being a collection of references that reference other objects. Given this model, it's now much easier to see what is going to happen on this line right here. Ret is set to refer to the same thing that ARR sub index was referring to. So since index was 3, 0, 1, 2, 3, in some ways you can almost picture the labels inside of here being the indices. So ret sub 3 is this box, or sorry, A sub 3 or ARR sub 3 is that box which references down to here, and so ret points to this object. Okay. So this is the picture that we have at the end of this line. What happens next? The next line is ARR sub index equals 0. Well, remember, these boxes are immutable. The int boxes are immutable. What's mutable in reality for the array is these arrows. And so I'm able to change this arrow right here. And so I make myself another box. And this is the box that has 0 in it. And now I change it so that the sub 3 points down to here instead of over there. But this box with the 4 still exists, and ret can still point to it, and everything is happy there. And then I return the value that ret references, so I give back the 4. So when I was done evaluating this, it gave me back the 4, and when we were done the array A, which ARR had been an alias to, this now points to 1, 2, 3, 0, and 5. So that's a proper model for what the arrays are doing, and hopefully this helps you to understand functions like get and clear. So that's it for this video. We'll come back in the next video and look at how passing is done, in particular pass by name semantics in Scala, to compare to the pass by value semantics that we've been looking at just now.